Hi folks, it's Mr. Robeson here with statistics. This is the last one for this semester, so make sure we pay attention. So this is 3.7. We're working with tree diagrams basically. So we're going to incorporate conditional probability and the multiplication rule to make tree diagrams, and then we're just going to look through some examples. So just a reminder, conditional probability, probability of B given that A has already happened. That's what this means. All right, sometimes it will change, sometimes it won't. That's where we have independent events versus dependent events. If this is just equal to the probability of B, then they are independent events. Most of the time it won't be the case, and we'll have a conditional probability for the probability of B. All right, the other thing we're working with is the multiplication rule. If we want to know the probability of A and then B, oftentimes we'll just say A and B. It's the probability of A times the conditional probability of B, given that A has already happened. And remember, if these are independent, then it's just probability of A times probability of B. But most of these examples will be the first one, not the second one. And you'll be given the conditional probability already. All right, so we're going to organize this stuff in a tree diagram. So what is a tree diagram? Well, it's made up of branching paths where each path has a particular probability of occurring. So we have a set of branches, like, say, here's a branch. And let's say we are flipping a penny and then flipping a quarter. So we flip a penny, we could get heads or we could get tails. All right, now we're going to go ahead and we're going to flip a quarter. Now going after the penny, we could get heads here or we could get tails here. And same with this one. We could get heads here or we could get tails here. All right, and this is basically what our tree diagram is. All right, so now to work our way along the tree diagram, the probability of getting heads, that's what this branch would be, because this is getting heads, would be 0.5. The probability of getting tails, when we flip that penny, that would also be 0.5. All right, and the same thing's going to work here. When we flip the quarter, probability of heads on the quarter is 0.5. The tails is also 0.5. I'm just not going to write the probability. That's going to be 0.5, and that's going to be 0.5, which means when we get to the end, so this would be heads and then heads, the probability of that would be 0.5 times 0.5. We're doing the multiplication rule, which gives us 0.25. All right, same thing's going to happen here. This is going to be the probability of heads and then tails. 0.5 times 0.5 gives us 0.25. This is going to be tails and then heads. Just reading what goes along this branch. So we start from here, we go out, we get tails, we go back this way, we get heads. 0.5 times this 0.5 gives us 0.25, and this would be the probability of tails for both, which is 0.25. And then we could ask questions like, what's the probability that both of them are heads? That'd be this. Probability both of them are tails, that'd be this. Probability that we get one head and one tail, that'd be adding these two together, that'd be 0.5. All right, we can do other stuff too. All right, so that's a basic one, and these were independent events. So the probability did not change. These were independent. All right, so now let's look at one where it's not independent. So at a certain school, all seniors take both statistics and English. Out of all the seniors, 80% are passing statistics. Out of those passing statistics, 90% of them are also passing English. Of those not passing statistics, 40% of them are passing English. So let's see. Let's start off with we'll do two branches here to start. And we've got passing statistics. Let's call that PS for pass statistics. And then FS for fail statistics. There's our first branch. Our second branch. Let's see, now we're also looking at English. So we got pass English and we've got fail English. And from this one, we also have two things that could happen. We could pass English or we could fail English. Oh, we should have started with F there. There we go. And let's see if we can put the probabilities on our tree here. So probability of passing statistics. Out of all the seniors, 80% are passing statistics. So that means we've got 0.80 here to get the passing statistics. That means the rest of them, 1 minus 0.80 is 0.20 or 0.2. 20% would not be passing statistics, so they'd be failing. Next branch, of those passing statistics, 90% are also passing English. So from this branch here, the top branch, out of this 80%, 90% of them are also passing English. Out of these two branches, that's got to be 100%, so that means 10% or 0.1 are failing English. Of those not passing statistics, so that's down here, 40% are passing English. That means 60% is what's left are not. So to get to this end, this is pass both, so passing statistics and passing English. This is 0.8 times 0.9 is 0.72. This is 0.8 times 0.1, and this is passing statistics, failing English, which is 0.08. If you notice, these two add up to this 0.8. Right here, we've got 0.2 times 0.4, which is another 0.08. And here we've got 0.2 times 0.6, which is 0.12. And you notice these two add up to the 0.2 branch. What is the probability that a senior is passing English? So we want to know what's the probability that we are passing, not statistics, English. All right, so passing English is here and here. So we're just going to add those two together. 0.72 plus 0.08, 0.8, or 0.80. What is the probability that someone is passing both classes? All right, so that means we are passing statistics and passing English. All right, well, passing both, that's passing statistics, so we're in the top branch, and then passing English is this end right here. That's just the 0.72. Now, this is where it gets tricky. Given that someone is passing English, so that means we're looking out of the people who are passing English, which are these two numbers right here, which, again, is this, the 0.8. So we're out of the 0.8, or 0.80. What is the probability that they are passing statistics? So now, out of only these two numbers, which ones are also passing statistics? Well, not this one, because that's the failing branch. So it must be the top one here. Yep, that's the passing branch. So those ones are passing. So it'd be 0.72 out of 0.80, or 72 out of 80, or we can change that to a decimal if we want. We can actually divide, but that's fine right there for ours. We'll do more examples, don't worry. All right, next up, let's make another tree. Let's pick another color. How about purple? A poll finds that 55% of responders are Democrats and the rest are Republicans. So let's see. That's our first branch then. So we've got Democrats and we've got Republicans. We got 0.55 that are Democrats. So that means 1 minus that is 0.45 that are Republicans. Of the Democrats, 90% think human-caused climate change is an important issue. So I'm just going to, let's see, how about C for climate change and N for not? And 0.90, and this would be 0.10, the 10% that don't. Out of the Republicans, 20% say human-caused climate change is an important issue. All right, so let's, again, same branch here for the Republicans. We got climate change and not important. 20% say important, so that means the rest, the 80%, say not important. So let's see, this is Democrat and climate change, and that's 0.55 times 0.90. Come back to that in a second. This is Democrat and not important, 0.55 and 0.10, which is going to be 0.055. These two have to add up to 0.55, so this will be 0.495, I believe. Yep, that looks like that checks out. And this is Republican and climate change. So we're multiplying those two together. So that's 0.45 times 0.20, which I believe is 0.09. And Republican and not climate change, it's 0.45 times the 0.80, which should give us 0.45 minus 0.09, which is 0.36. All right, so there's the probability of all of our branches. Now we should be able to answer all of the questions. What is the probability that any responder thinks human-caused climate change is an important issue? So those are the C's. climate change, climate change. So that's this number and that number. So that's 0.495 plus 0.09, which is going to be 0.585, I believe. Doing the math here in my head on the fly. Number 2, what's the probability of a person in this poll being a Democrat and thinking that climate change is an important issue? So we want D and C. That's this top one. So that's just this number right here. So that is the 0.495. And finally, out of those who think climate change is an important issue, so climate change is an important issue was this one and that one, which was the first answer here, the 0.585. Out of them, what proportion are Democrats? So out of these two numbers, these top ones are also Democrats. So that's the 0.495. And there's our answer. All right, so that's how the conditional work. We look at the total and then we put the out of on top. All right, last example here. And now this one's independent, so this one works a little different. We'll go with blue. The poll finds that men and women are equally likely to save money for retirement. 70% each say that they save money. Out of those surveyed, 40% were male and the rest were female. So now it doesn't really matter which one we do first here. So let's do male and female first. So we got 40% were male, and that leaves 60% to be female. Out of the males, 70% are saving for retirement. That means 30% are not. We'll say retirement and just N for no. And for the females, we got retirement and no also. And again, it's also 70 and 30. So this is male and retirement. 0.4 times 0.7 is 0.28. This is male and not saving for retirement. 0.4 times 0.3 is 0.12. Female retirement. 0.6 times 0.7 is 0.42. Female not retirement. 0.6 times 0.3 is 0.18. We can check, do these add up to 0.6? They do. Did these add up to 0.4? They do. All right, that works out. All right. What is the probability that a survey responder was a male who was saving for retirement? All right, well, male retirement, that's just the top one here, 0.28. What is the probability that a survey responder is a female who is saving for retirement? All right, let's see, female retirement, that's this one right here, 0.42. Given that a responder is female, well, let's say 60% are female, or we can say it's these two added up. But given that it's female, means out of the 0.60 or 60%, what is the probability that they are saving for retirement? So female retirement would be 0.42. And if we do divide those, we do get exactly 0.7, which is the 70% that are saving for retirement. All right, that's the beauty of independence. It's going to work out to the same thing. All right, and that is it for the notes today. So check out the assignment on Google Classroom. It's the last one, so please do get it done.